Hey guys, welcome back. So in this module, we are going to discuss what is the impact of power factor on the system on board ship. So we can explain that through this very famous picture which you may have seen earlier also, that we can explain power factor through this a glass of beer where the complete volume of the beer glass is showing me apparent power.
Hi ETO aspirants, Jai Hind, Jai Bharat, Jai Mata Di. I hope you like this video. Always aim for joining top-notch companies with top-notch sponsorship in shortest time possible, because time is money and time is never going to come back. I have got two solutions for you. One is ETO Aspirant Excellence Package on Merchant Navy Decoded platform. Online courses, watch at the comfort of your home. Second is 100% results, faster results. Come to SMVD Marine Academy offline coaching. Jai Hind, Jai Bharat, Jai Mata Di. Choice is yours. Link is in description box.
So what is an apparent power? All the power that is coming from alternator that is going to bus bar is apparent power. In that, true power will get consumed in the load. The load could be motors, heaters, and could be other loads. So this is the power that is getting consumed in the process. So the power which is getting consumed is the one that will be shown in kilowatt in the kilowatt power meter on board ship. Some of the power which is called reactive power, this does not get consumed in the process. This comes back into the system, and this is this power which is responsible for setting up of magnetic field in the motors. Motors, transformers, solenoid coils, all those load which are inductive type, where this power will be used in setting up of the magnetic field. And I previously showed you this inductive portion of the power, it is not getting consumed in the process. It comes back. You give it, it comes back. So that means half of the cycle I am providing this power, another half, then it will come back to me. Means it is assisting my alternator motion. So that means this is not leading to any fuel consumption. This is not leading to any fuel consumption. It is this one which is leading to the fuel consumption. But if this is leading to fuel consumption, then why are we bothered about apparent power? See, the problem is I can only fill this glass till this point. However, this much is used up by the customer. This is not. This comes back to me. So if the apparent power is also limited, my alternator cannot provide more than certain apparent power, because otherwise this glass will overflow. Same is the case with alternator. That means my alternator can provide voltage, it can provide current, and multiplication of both of them is my apparent power. But some portion of the current, I cos theta, is the one that is taking part in load transfer to the motors and other equipments. However, this another component that is I sin theta, so you can just draw it like this. This is I cos theta and this is I sin theta, or if I you can call, and this is I. So only this component is used up in active power. This component is used up in setting up of magnetic field. So this is not getting consumed, it comes back. But my alternator is providing this thing, not combination of these things, not only this. So I will have to provide I sin theta component of current also. That means which will limit the overall power output from my alternator. That means if the power factor is more in the if reactive power is more and my power factor is less, so best power factor will be how much? 1, which is not possible if on ship, because a lot of loads, motors, inductors are there, and that's why it is not possible. But best is this. But if we come to, let's say, 0.5 only, power factor becomes 0.5. That means out of full glass I am only able to consume, this is the only beer part, rest everything is froth, and this is only which is useful for the customer. Though from my pocket I'm only, while buying the beer, I'm buying this much beer only, but I will not be able to provide it to the customer. Because my glass becomes full, it will start to overflow, means the froth starts to come out. So what is happening is, what is the limitation? If the power factor is really bad, my alternator size has to be made bigger to compensate for this kilowatt, because kilowatt is dependent upon the load on the system. This is dependent upon the load. This also is dependent upon the load, but yes, if the number of reactive loads are more, if the inductive loads we start more, power factor will become bad, means it will come down from 1 to some other values. So in that case, I will have to employ a bigger alternator to provide big current, and only small amount of that will be useful. Rest keeps coming back to me again and again. So ideal value of power factor would be 1, which is not possible on ships. So you have to make sure that somehow you need to control the power factor and not let it go below 0.8. 0.8 is normally that is agreed load power factor on the ships. So if you go below 0.8, then it's not so good. So your alternator may not be able to provide the required kilowatt load on the ship, because your alternator is only providing the apparent power, out of which if you are only consuming this much and you give this much back to me, then this is not the mistake of the alternator maker. It says I can provide this much, but you are only consuming this much. Right? So this is how the power factor is useful. So the higher the better. That means higher the value of power factor, that is close to 1, the better it is. Okay, that's all for this video. Thank you so much. See you again.